Hi everybody, and welcome to the first video on functions. So there are several topics in this course that we have covered and will cover that are at the heart of computer science. And all of these topics, I might get fired from teaching this course if I didn't teach you some of them. So the key topics are if statements, loops, lists, where by lists I mean both vectors and arrays, and now functions. So functions are just a big concept, a big topic that is at the heart of computer science and is foundational. And again, if I didn't teach you what functions are, I would probably not be allowed to teach an introductory C++ course anymore. So they're very important. And to motivate you what they do for you, let me just show you an example. So here's a program I wrote that's pretty bare bones here, but all it does is it declares a 2x2 array, and it lets the user fill in the entries for that array. So the first thing the program does is it tells you what array you entered. Like it says, okay, here's your array. And then it does this little nested for loop to print out the entries. And then the next thing it does is it computes the transpose. So this nested for loop guy right here computes the transpose, and then it prints that out to the user. So if this doesn't make sense to you right here, this was in a previous video, how you can calculate the transpose of a matrix. But in any case, I compute the transpose and then I print it to the screen. Okay, here it is. The next thing I do is I swap the rows of the matrix that the user entered, and then I print, hey, here's what you entered with the rows swapped. And then I have a nested for loop that prints that matrix. Okay, that matrix is called rows swapped, appropriately enough. And then finally, I swap the columns, and then I say, hey, here's the matrix that you get when you swap the columns. And then I have this nested for loop again that prints columns swapped, which is the matrix that just swaps the columns of the matrix that the that the user entered. Okay, and then the program stops. So if we run this, I can enter a matrix, and so 1, 2, 3, 4. Okay, easy enough. So it starts by saying, here's what you entered, 1, 2, 3, 4. Here's the transpose, so it swaps the rows and columns. Here's where it just swaps the rows, so 3, 4 becomes 1, 2, and 1, 2 becomes 3, 4. And lastly, it swaps the columns. Okay, so again, if any of this code confuses you, this is previous material, so you can go back and watch the videos on two-dimensional arrays if any of this confuses you. But what I want you to focus on right now is that I had 4 separate instances inside this program where I wanted to print an array. So here's the first instance. I print the array that the user gives me. It's this nested for loop that goes from 0 to 1 and doesn't do 2 because it's just a 2x2 matrix. And then I print the transpose. And it's the same loop, except now I have transpose written right here because I'm printing the transpose array now, not the original array. And then I print again a 2x2 matrix, but it's this 2x2 matrix, the rows swapped matrix. And then I print again, and this time I print the columns swapped matrix. Okay. So as I was typing this code, I started getting annoyed at how often I was typing basically the same thing. Right? So this chunk of code right here, all it does is it prints the array that I tell it to print. So this chunk of code right here is the same as this chunk of code, except the name of the array changes. And this chunk right here is the same as this chunk right here, except again the name of the array changes. And this chunk right here is the same as this chunk right here. Right? So when I was writing this code, I just did a lot of copying and pasting of the same code and changed the name of the array in there. Okay, so this is obnoxious to have to repeat the same chunks of code over and over again. I mean, it's not literally the same code because you changed the name of the array, but the task that this code is performing is the same every time. It's just printing whatever array I want it to print. So what I'd like is just some command that says, hey, print array, and then I want to tell it the name of the array, so maybe I want to print the array the user gives. Right, so what I'd like the computer to do is say, oh, what he's telling me to do is just print this array. And then maybe like later on in the code I could have it print the transpose, you see? So it's yelling at me. There's like a red warning sign over here. This won't compile because I haven't taught it what it means to print an array. Okay, that hasn't been defined. But what I'd like is just some sort of protocol like this where I can just tell it, look, print the array, and somewhere I'm going to define for you, computer, what print array means. And print array will basically just mean these nested for loops, okay? But rather than just writing these nested for loops every single time and just changing the name of the array, it'd be nice to just have a single line of code that you could call on that just says, hey, print this array for me, please, so I don't have to copy and paste the same code over and over again. So that's the idea of a function. A function is what we're going to write later that essentially just lets me write lines of code like this, where somewhere else in the code I tell the computer what I mean by this print array. Okay, so right now I haven't defined that. But basically a function is just a chunk of code that performs some specific task. So you can just call on that code anytime you want that task performed, rather than writing the same chunk of code over and over and over again. Okay, so imagine that this program here, maybe I don't just care about a 2x2 array. Maybe I want the user to enter lots of arrays, and maybe I want to do lots of things, not just transpose, not just swap the rows. Maybe there are all sorts of other things I want to do, like maybe compute the inverse of the array or whatever. And every single step, maybe I want to keep printing the array. Well, I don't want to have to keep writing the same stupid nested for loop every time, right? This one, where all I do is change the name of the array. I would just like, imagine having to do that thousands of times. That would be obnoxious. Okay, so that's the idea of a function. So a function is simply a block of code that performs a specific task, or maybe more than one task, depending on what you want it to do. And if your code needs to perform the specific task more than once, using a function lets you write code for that task only once. Okay, so suppose that you know that inside your code you're going to be printing multiple 2x2 arrays. I'm going to be printing 40 2x2 arrays, whatever. It makes sense to separate out that print function from the rest of the code and just call on it when you need it, rather than writing the same code over and over and over again. Okay, so you can either write the print code 40 times, or just write it once and call on it 40 times. So writing it once and calling on it 40 times is way easier and much more efficient than writing the same code 40 times. So functions, they streamline your code. It separates different tasks into different chunks of code, and then basically you assemble your program from these individual function chunks. So essentially, we're going to now treat programs, when you have functions floating around, you can treat programs like furniture to be assembled from separate pieces. Okay, so each function is a separate task, and when you assemble all the tasks together, you now have a fully running function that does whatever it is you want it to do. So before I show you how to code functions, here's a question that we should ask. So most of you have been taking math courses for your entire life. You have certainly used this word before, but it's not clear if you've really imbibed what this word means. Okay, so let's talk through what this word means. So from our perspective, a function is an abstract machine. You give the machine an input or a list of inputs. You can give it 1 or 10 inputs depending on what function you're talking about. And the function returns one and only one value according to some rule that you have defined. Okay, so you feed stuff in, the function does something with the stuff you fed in, and then it spits out one and only one value. So the one and only one is what makes it a function. You can feed in as much as you want, but out pops a single thing. So here's a simple function, right? This is like a function you saw in Calc 1 or whatever. Okay, what does this function do? You feed in a number, and this function spits out 2 to that number. Right? So this equation here is defining a rule for how the function is going to return something, how the function is going to spit something back at you. So for example, if you input 3, the function outputs 8, because 2 to the third is 8. So in function notation, f of 3 is 8. Okay, so again, I think of this as a machine. I feed something in, it spits something back at me according to this 2 to the input rule here. Pretty much anything that you deal with in say algebra or in arithmetic is a function. Addition in particular is a function. You input 2 parameters, a and b, and the function returns their sum. So if you feed in like 2 and 7 to the addition machine or the addition function, the function returns the number 9. So here 2 and 7 are your input parameters and 9 is your output. And you don't write it this way, but this is how like an algebraist would write this. Okay, in function notation, you feed in 2 and 7, you add them, and you get back their sum. Think about a function that takes 7 numbers and returns their average. So this function has 7 inputs, x1 up to x7. You have to hand it 7 numbers, and the machine returns their average. It spits back at you this quotient right here. Okay, so that's the idea of a function. You can feed in a bunch of inputs, or maybe only one input. The function does something with those inputs, and whatever it does is defined by you, and then it spits something back at you. It returns something to you. So here's the global framework of what a function is and what it does. You hand a function a list of inputs, or in fancy language, parameters. It's sort of the fancy computer science language. So you hand the function a bunch of parameters. The function then performs a specific task with those parameters, and sometimes it gives you a value back. Sometimes it doesn't, but when it does give you a value back, there's only one value. The function performs its task according to some rule that you have defined. So you tell it how it's going to perform its task, right? You tell it what task it's going to perform. So in C++, when we build functions, we have to do several things. We have to give the function a name. So in this example here, the name of the function is f. Okay, but you can call it anything you want to. You can call it my function, you can call it stupid function, whatever. Give it whatever name you want. You have to tell it how many inputs you're going to be giving it, and what the data type of each of those inputs is. And finally, if it's going to return something, you have to tell it the type of thing it's going to return. So with this addition example here, right here, maybe you only want to hand the addition machine whole numbers. That's fine, but you would have to tell the computer that that's what you're doing. I'm going to hand you 2 whole numbers, and then you have to tell the computer that you're going to return a whole number. So when you add 2 whole numbers, what comes back to you? Another whole number. All right? Okay. You have to be a little bit careful here, because think about division. If you hand a division machine 2 whole numbers, you're not going to necessarily return a whole number. Right? If you do 3 divided by 2 and you don't want to do integer division, you get 1.5 back. So you have to specify the data type of your return value, which in that example would be a decimal. Okay. So this is what you're going to have to tell the computer. A name, how many things you're handing it, what data type each of those things you're handing it is, and the kind of thing that the function will return, if indeed it returns something. Okay, so let's just consider this example here. F of x equals 2 to the x. Suppose that many times throughout your code, you need to compute values of that form, right? You need to compute 2 to the 3rd, 2 to the 7th, 2 to the 8th, whatever. So you could just write this line of code every time, pow 2x, right? But maybe you don't like that. Maybe you don't want to write pow 2.3, pow 2.7, pow 2.8. Maybe you just like to write f of 2, f of 7, f of 8. That's faster and it fits more with this function notation here. So in other words, you don't want to write pow 2.4 every time. You want to write just f of 4. And the computer should then know that that means 2 to the 4th. Okay, so to do that, let me just, rather than showing you on the slides, let me just clear this out and show you how that goes. So first of all, I want to build this function in C++. That function has a name. The name is f. So let's just call it f. If you want to declare a function, you declare it above main. And so notice that, let's just say that in this setup, we want to feed any real number into this that we want. So we want to input any real number we feel like. So we would have to declare this function as a float function. And we call it f, and then we tell the function that I'm going to feed into you a float value. Okay, so what is this saying here? This is saying that, first of all, the name of the function is f. Then you're telling the computer, I'm going to feed in a single input. So only one input, and that input will be of type float. And then you, computer, will do something, and you're going to return something of type float. So this first value here is what the return value is going to look like. So imagine in this example here, if you feed in the number 1/2, you're talking about the square root of 2. And the square root of 2 is a decimal. So you feed in a number and you get a decimal back. So that's what you're telling the computer here. I might get decimals back. And I'm going to feed in decimals. And now below main, you now retype the same line of code. But now you teach the computer what f is. So what I'm going to do now is just say float y, and let's just let y equal how to x. Okay, so I fed in a float value, to a, sorry. So I fed in a float value a, I've created a variable y, and y will simply be 2 to the a. And then what I'm going to do is, I'm going to tell the computer, okay, spit back the value y. Okay, so what has happened here? The user is going to feed in a number here. The computer is simply going to compute 2 to that number, and then it's going to spit that number back at you. So if you feed in 3, the computer should return 8. Right, if you feed in a 3 right here, the computer should spit back 8. So let's just see how that works. Now up in main, I can actually now just write something like that, f of 3, you know. Now the computer knows what that means because you've told it what you mean by f. So let's just run this and see what it prints. It prints 8, okay, because 2 to the 3rd is 8. And I could ask it to print, 2 to the 5th, and it will do it. 32, okay. Now notice, if I comment this out, okay, now I can run the same thing. The build fails, okay? The computer doesn't know what to do here. The computer now is like, what is f? You haven't taught me what you mean by f, so I'm not sure what I'm supposed to do with that. But now if I uncomment all this, oh, now I've taught it what f is. F is the function that when I feed in a number a, the function returns 2 to the a. Okay? So before I move on, let's now just do like this. Okay, let's say that C is 4 and C is 4. Let me now show you the first thing that can, well, one of the many things that confuses students about functions, okay? This certainly takes getting used to. So what happens here is I create an integer variable called C, and I set it equal to 4, and now I say C out f of C, okay? One thing that confuses students is that this letter right here is C. This variable right here is A. They don't match, right? I'm trying to feed in C, but what I'm telling the computer down here is I'm feeding in an A value. Okay, so what's happening here is this is just a catch-all term for like, look, I'm going to feed you a decimal, and I have to give that decimal a name down here so I can manipulate it inside the function. But it doesn't matter what you call your decimal up here. As soon as you put it in the parentheses for f, you're just feeding that variable down. And now, like if C is 4, then A will be treated like 4. And I'm still going to return 2 to the 4th. So let's just run that and make sure it does it, right? 2 to the 4th is 16. Okay, so here's one thing that is certainly an initial trip up with functions. You have a variable here called C. The variable down here is called A, but the value of C gets put in the value of A. And now the value of A is whatever C was, and that's how it's treated throughout the function. So when you see an A right here, that value of A is 4, because 4 is what got fed into the function. Okay, but anyway, here's a function where you can just, instead of writing pow of 2a every time, you can teach the computer, oh, I'd rather just write f of it, write f of 2, f of 3, whatever, and the computer will know what that means. Okay, so let's come back to this. So we've now written a function that does that, right? That now instead of writing pow to 4, you can just write f of 4. Or pow to c, you can write f of c, whatever. Now let's write another function. Let's write a function that returns the average of 2 integers. Okay? So what does that look like? Well, let's keep our old function here. The first thing to remember is that the average of two integers is not necessarily an integer. Okay, the average of 2 and 3 is 2.5. So this function is going to return decimals, possibly. Okay, and let's just give it the name average. And now I have to tell the computer, I'm going to give you two values this time. I'm going to give you two integers. Okay, so if you want to compute the value of two integers, you have to give the function two integers. You have to give the function two inputs. And now I'll just come down here, and now I'm going to define the average function. Okay, so I feed in a couple of integer values, and now let me just return a plus b. Oops. And I have to cast the division because I want to return the actual division value, not integer division. Okay, so all that's going to happen is whatever values I feed in to the function, I'm going to take those two values and add them and divide by 2 to get the average, and I'm going to return that. So let me just come back up here and let's just say like int x, and let's make x the float x equals the average of 2 and 3. Okay, and then let's just see what x is. So notice this average word lit up blue. That means that the computer now recognizes that you've taught it what that word means. So now if I run this, I get 2.5, which I should get. Right? That certainly is the average of 2 and 3. Okay, yeah, let's write one more function. Okay, so here, let's write a function that determines whether or not a quadratic equation has real solutions. So just to refresh your memory on this, you wrote a program that dealt with these before, but just to refresh your memory, a quadratic equation is any equation that can be made to look like this. Okay. It might not be handed that way to you at first, but you can always write 0 on one side or the other by grouping everything else together. So if you have an equation like this, the quadratic formula says that the solutions come in this form. You have negative b plus root b squared minus 4ac over 2a, and negative b minus root b squared minus 4ac all over 2a. So here are the solutions to the quadratic equation. However, whenever you're taking a square root of something, you have to worry about taking square root of negative numbers. So in this case, this quadratic equation has real solutions if and only if you're not taking the square root of something negative. So let's write a function that detects whether or not this equation has real solutions or not. And before we do that though, let me just make a quick aside. We've briefly mentioned this before, but let me bring it up again. A Boolean variable or a Boolean statement, whatever, something Boolean can only be true or false. So a Boolean variable is a variable that can only be true or false. Those are its two variables. Those are its two possibilities. You declare a Boolean variable with the syntax bool. So the computer knows what bool means, and then give it a name. So over here I can be like, bool my variable, and I can make it true if I want, or I can make it false if I want. Those are the two options for a Boolean variable. There are no other options. I cannot write 3 right there. Okay, it won't know what to do with that. So if I run this, it built, but yeah, I wonder what it's going to do. Let's see out my variable. It output a 1. Okay, so it doesn't really know what to do with this. So in Visual Studio, it might not even compile with something like this. But notice it didn't print a 3. Okay, so it finds that confusing. So Boolean variables only have two possibilities, true or false. Okay, so back over here, let's write a function that returns true if this function has real solutions, and returns false if that equation doesn't have real solutions. So let me just declare my function up here. So it's going to return a truth value, either true or false. And let me just call it has real solutions. Okay, and now what do you have to feed into this function? Well, to completely describe a quadratic equation, Let me make this big. To completely describe a quadratic equation, you have to hand it all three coefficients, an a value, a b value, and a c value. Okay, so you have to hand the function three inputs now. And let's just assume that they're all integers. You can, of course, tweak the function to handle decimals, but for now, let's just have integers. And now let me just come down here. So when I make this function, all I want to do is check whether or not this condition is true. And if that condition is true, then I'm going to return true because it does have real solutions. But if that condition is not true, I will return false. So let me just write that. If b times b, minus 4 times a times c, if that's greater than or equal to 0, then the equation does indeed have real solutions. I did not take the square root of a negative number. Oops. So I want to return true. So it's true that this function has that this equation has real solutions. But otherwise, I want to return false. Okay, so if b times b minus 4ac is less than 0, that means I'm trying to take the square root of a negative number, so I won't have real solutions. So let me just come back up here, and let me just really strip this down. A, B, C, and let's just get those three numbers from the user. Let's not make this user friendly. Okay, now let's write something like this. If has real solutions when I feed in A, B, and C is true, then let me just tell the user your equation has real solutions. Maybe only one, but it has some. Otherwise, no real solution. Okay, so what's happening here? I'm getting the three coefficients from the user, right? I'm giving the a value, and the b value, and the c value. If I feed those three numbers into my function that checks whether or not they are real solutions, and I get true back, that means that there were real solutions, or at least one of them. But otherwise, there were no real solutions. So hopefully the way that you name things and the way that you set things up makes sense in English to you. So this is literally saying, if has real solutions is true, well then I should have real solutions, right? So the English here makes sense based on the names that I've given things. So let's just run this and make sure it works. Oh, okay, so if I do 1, 0, and now 1 before I hit enter here, you can check on your own that this equation has no real solutions. So let's just see if this works. No real solutions. Okay, good. If I do 1, 0, negative 1, so A is 1, B is 0, and C is negative 1, again, you can check on your own that this actually does have real solutions. The solutions are 1 and negative 1. So when I hit enter here, the computer should tell me that there are real solutions. Okay, and it does. Okay, so to conclude this example, let me just point out that in that quadratic equation solver you guys made, the first thing you had to do was check whether or not the equation had real solutions. And then if it did, you had to find those solutions. Writing the program like this helps streamline what you are doing because you've taken the task of checking whether or not there are real solutions, or you've taken that task and separated it out into its own separate subroutine down here. Okay, so we're going to spend quite a bit of time on functions, mainly because they're super useful, but also they take a lot of getting used to. But one of the main reasons that they are useful is because it can really help streamline your thinking. So up in main here, you can really just focus on the big picture. So up here in main, I didn't worry about checking whether or not things had real solutions or not because I sort of outsourced that task to a function. So up in main, everything is real streamlined and very clear as to what you're doing because you're just sort of like separately calling on these subroutines that you've created. So it helps really streamline the task at hand in main. So in the real world, when you look at somebody's code from like an engineering firm or something, they will just have like hundreds or thousands of functions, okay? Because otherwise main is just so bloated And it's just so unclear what's happening in main that it's really hard to read. But these engineers take these sort of like sub-functions, these tasks that they want the computer to do over and over again, and separate them out into separate blocks of code that they just call on when they need it. And it really makes the code a lot clearer to both the writer and the user. Okay, so again, these take getting used to, so we're going to spend some time on them. But for now, here is an introduction to functions.